For this last problem, we have a computer represents information in groups of 32 bits. We are asked how many different integers can be represented in binary, BCD, and 8-bit ASCII. First, we are going to start out with binary. And for binary, we know it's written as 2 to the n plus 2 to the n plus 2 to the n, and so on for as many n's as we have. And for here, our n is going to be this 32 bits. So really, this is going to be 232. And if we plug this into a calculator, we're going to get that this is 4,294,967,000 with 296. So that's how we would go about solving for the binary part. Now for BCD, there is a chart to the left right here. And for BCD, since we're dealing with 32 bits, we have to look out for our limit. Every 1 byte in BCD is equal to 2 decimal places. So for every 1 byte, we are going to be able to write out 2 things. Well, here we have 32 bits. And we know that 1 byte is equal to 8 bits. So if we were to write this out as 4 bytes, that means we would have 32 bits. And 32 is our limit. Well, if 32 is our limit for here, if we have 4 bytes, but we were to write it out in decimal digits, we would basically be multiplying this over by 2. So we would do the same here, where we would multiply this over by 2, and we would be getting 8 decimal digits. So we would be able to write 8 decimal digits, and for all the different possible combinations, because this is asking us for how many different integers can be represented, we would be having 0, 0, 0, 0, 0, 0, 0, 0. So we have 8 zeros because we have 8 decimal digits, and we could have as many different combinations all the way up to 999, 99999. And the reason why these are the start and stop points is because this 0 is when they're all 0, and then 9 is when they're like this. So these are the two stop points. And if we look at this, we can go 1, 2, 3, 4, 5, 6, 7, 8. So this is basically 10 to the 8th if we move this over here. But if we add this to this, it's basically 9999, 9999 plus 1, which is equivalent to 10 to the 8th. So that's how many different integers are represented. For C, we're looking at 8-bit ASCII. And for 8-bit, unlike previously where we had 1 byte is equal to 2 decimal places, 1 byte is going to be equal to only 1 decimal place. And for here, it's equal to 2 decimal places is because every single byte contains 8 bits. And the BCD only takes up 4 bits. We can see that it only takes up 4 right here. So it'll have this 4 and then like another 4 in the same byte. However, 1 byte is equal to 8 digits. So we would be having 4 here and then 4 here. And that'd be a single byte for 8-bit ASCII. And if that's the case, we'll have 4 bytes is still equal to 32 bits. That doesn't change. However, 4 bytes is only equal to 4 decimal digits. And we can see that this will hold true because we have 4 decimal digits and then we have the 8 bits, and the 8 times 4 will lead to this 32 bits. So we're going to basically have 0, 0, 0, 0, and this will go to 9, 9, 9, 9. And then if we did the same thing we did here, we would basically just have 10 to the 4th. So that is the equivalent there. So those are all the different integers for each of the different scenarios that can be represented in binary, BCD, and 8-bit ASCII, all using 32 bits.